polynomials. So we have our third worksheet dealing with polynomials, and we are going to learn about, first of all, adding. We have two Chewbaccas here, and in order to get rid of the parentheses, we can distribute. There's an invisible 1 here, if we want to think about it, and it's being distributed into each of these three terms, 1, 2, 3. And we know that that's not going to change anything, so this just becomes 7x to the fourth plus 2x to the third plus 5x to the eighth plus 8x to the third plus 12x to the fourth plus 2x to the seventh. Now, we want to look for like terms. Anything with the fourth? Yep. So when we have like terms have the same variable to the same exponent. We're going to combine their coefficients. 12 and 7. 12 and 7 make 19x to the fourth. Is there a match for x to the third? Yep, right here. We're going to combine these coefficients to make 10x to the third. And then we have x to the eighth, doesn't have a partner. And let's do this in purple. And x to the seventh doesn't have a partner. So those just need to be brought down. 5x to the eighth. And 2x to the seventh doesn't have a like term. Now we have to put it in standard form. So we're going to do alphabetical order. We notice they all have x as their first variable, and then we're going to do exponent. So 5x to the eighth plus 2x to the seventh plus 19x to the fourth plus 10x to the third. That would be the answer in standard form, and we would have simplified. Notice right answers in standard form. Good, I'm glad that they focus on that. This one, again, we have a -1, and we distribute. This time it will affect those numbers inside. So 30x squared y minus 7xy squared. Now a -1 times -2 is positive 2xy to the second. -1 times positive 10x squared y gives us negative 10x squared y. Like terms have the same variable to the same exponent, so x squared y, we're going to combine their coefficients. So 30 and -10 make 20x squared y. And now we have xy squared, so we'll combine these. Those got combined. And that gives us -7 positive 2 is -5xy squared. And now we want to look to make sure it's in standard form. So we go with our leading variable, x, that's x. So alphabetical, they're the same. Now we go to their exponent, x squared, x to the first. X squared is going to come before x. So this is in standard form. We're going to distribute again. So we've got all these different coefficients, which is kind of not fun. Well, let's do, yeah, I could turn that. I guess I can turn all those into decimals. So we'll convert them all to decimals. 1/50th, so 1/50th. 1/50th is going to be 2/100ths. So I think that's that as an exponent. This is -0.25 w. That's going to be plus 1.125 w to the fifth minus 0.1 w cubed. Let's make this all a little bit smaller. Let's group it. Make it a little bit smaller so we can write. Let's make our writing a little bit, minus 0.1 w minus 0.2 w. Let's do blue. Let's mark them up. So w to the fifth, good. Let's combine their coefficients. That is going to give me, 2.82 25w to the fifth. Let's combine these. So w to the second, there is no w to the second. So plus 0.2w to the second. Let's do that color. W to the first. Yep, we've got a w to the first over here. Negative, negative. So that's going to make negative 0.45w. And then let's do the last one. We'll make it purple. And that's negative 1. And there's no match to that. So negative 0.1 w to the third. Let's put them in descending order. 2.825 w to the fifth minus 0.1 w to the third plus 0.2 w squared minus 0.45 w. That's a horrible 5 right there. Oh, I should make that smaller. To the fifth w. Now I see double on w's. Good. So that would be our answer in standard form. We've combined all like terms. We're good to go. All right. When we have the multiplication of two binomials, it's called double distribution. We have this term, and we're going to distribute it into both of the terms in the other. And then we're going to take this term and we're going to distribute that into both of the terms in the other. So, and then it looks like that. So if we do the steps, x times x plus x times negative 7 plus 5 times x plus 5 times negative 7. So we distributed that first term, positive x, to both the 5 and the negative 7. So here is, sorry, not to the 5, to the, let's get something a little bit lighter shade. That's there. So the x goes to the x goes to the negative 7, and then the 5 goes to the x, and then the 5 goes to the negative 7. So if we simplify that out, we've got x times x, which is x squared, x times negative 7, which is negative 7x, 5 times x, which is 5x, and 5 times negative 7, which is negative 35. We also have like terms as our middle. This is called first, outer, inner, last. Our firsts in both of the binomials are outside 2, my inside 2, and then the last of each of the binomials. F-O-I-L, first, outer, inner, last. These are the inner 2. These are the outer 2. These are the first of the binomials. Here are the last of the binomials. That's why they call it first, outer, inner, last. And you're always going to, well, not always, but you're going to be able to add your outer and your inner. And so you get x squared minus 2x minus 35. That was a bad 5. As your answer. You can't combine these. These are unlike terms. So here we've got multiple ones. So orders of operation tells me to multiply these two binomials first. So we got x times x plus x times negative 4 plus 4 times x plus 4 times negative 4. That's the first, outer, inner, last. X times negative 4, 4 times x, 4 times negative 4. And then that's going to multiply 2x plus 3. So let's simplify this. This becomes x squared minus 4x plus 4x minus 16 times 2x plus 3. And these are like terms. Here's my outer and inner. They actually cancel each other, and you're left with x squared minus 16 times 2x plus 3. And you need these parentheses here. These parentheses don't break off because it's still a product. We're taking this product and multiplying it by this last term. So we still need parentheses to show that we need to distribute this also. So we're going to do x squared times 2x plus x squared times 3 minus 16 times 2x minus 16 times 3. X times 2x, x squared times 2x is 2x cubed. X squared times 3 is 3x squared. This gives us negative 32x. And this is going to give us negative, what's that, 1848. No like terms. It's in standard form. X to the third, x to the second, x to the first, no x, or technically x to the 0. This is 5w squared. We need to understand that this is a variable. A term is being squared, so it's technically 2 of the base, 5w minus 3. So 5w times 5w plus 5w minus 3 minus 3 times 5w minus 3 times negative 3. That gives us 25w squared. That's negative 15w minus 15w plus 9. These are like terms, which gives us 25w squared minus 30w plus 9. Good. So this is called a binomial square. It's a binomial that's being squared. Oh, sorry, I went the wrong way. This is called the difference of square, or this is conjugate, sorry. These are called conjugates. And conjugates are opposite of each other. So anything, well, let's not do it in red. Let's do it in black. Conjugates. Conjugates produce the difference of two squares. Conjugates are like x plus 3, x minus 3. And you'll notice that you're going to square that because that's identical. These are identical except for the difference in their signs. So it's x times x, which is x squared. Your outside and your inside are going to be opposite of each other every single time. And then your lasts are going to be negative 9. It will be that number, the opposite of your value squared. So if you wanted to see it, it's kind of like a plus b times a minus b. And what that's going to create is a squared minus b squared. So you can take your a value squared minus your b value squared. So if we look, these cancel each other and you're left with x squared minus 9. So it's your a squared minus your b squared. Real nice and easy. That's the shortcut. So if we get something like m minus 10, m plus 10, they are conjugates. They are identical except for their signs. So we can see that it's going to be m squared minus 100, or 10 squared, which is m squared minus 100. Because your outside and inside are always going to cancel. That's positive 10x, that's negative, or positive 10m, negative 10m. So that's going to cancel. And even if it gets very complex, like 2x minus, let's say, 7 and 2x plus 7. So those are conjugates. So your a is 2x quantity squared minus your b value squared. 2x squared is 4x squared minus 49, way faster than double distributing. Okay, so that's with conjugates. That's the shortcut for conjugates. Let's move that action. Yeah, we can do that. And then there's a shortcut for binomial squares. This is, we'll call this binomial squared because it's a binomial and it's being squared, and there are shortcuts with that. So if we notice, maybe you did or maybe you didn't notice the aspect of that. So if we have x plus 3 quantity squared, that's x plus 3, x plus 3. Was that what we did? No, good. X plus 3, so you're going to get x squared plus 3x plus 3x plus 9. And notice that your inside and outside are always going to be identical because your a and b are identical here. So instead of being opposites, they're going to be the same. So you're going to double this. You're just doubling that. So it's x squared plus 6x plus 9. So you're still squaring your a. So seeing it's a plus b quantity squared gives you a squared plus 2ab plus b squared. So you're going to multiply your a times b. So the fun, fast one, and let's do x minus 5 quantity squared. It's a squared, your x squared, plus 2 times a times b, b is negative 5, plus negative 5 squared, your b value squared. B is negative 5, a is x, so you get x squared minus 10x plus 25. And then you can do something a little bit more technical. You can do 3a minus 4 quantity squared. Now let's do plus. So remember, it's going to be a squared plus 2ab plus b squared. Your a value is 3a, so quantity 3a squared plus 2 times your a times your b plus your b value squared. That's 9a squared. That's 2 times 3 times 4 is 24a, and then plus 16. So that's a little quick instead of writing it as 2 and doing the double distribution. Oh, I didn't need that. Let's delete that. Delete that page. All right, this is just a distribution. This square is only applied to this base, so this is not a squared. We're just going to distribute, and I'm going to turn it into 1/4 y because I can multiply that a whole lot better. So 1/4 y times 7y is 7/4 y squared. I guess I should write it. Don't get lazy, Mr. Mac. 1/4 y times 7y plus 1/4 y times negative 12y squared. That negative is attached to the 12, not the 1/4. 1/4 times 7 is 7/4 y times y is y squared. 1/4 times negative 12 is negative 3. Y times y squared is y cubed. And then we would write it in standard form. So y to the third is going to come before y squared. And that's probably the tricky part of that one. We can't subtract. We're going to have to do this multiplication before addition and subtraction. So we will distribute this. You get 5k times 1/3 k squared plus 5k times negative 8 minus 2/3 k cubed at the end. This gives us 5/3 k cubed. This gives us negative 40k, and then minus 2/3 k cubed. These are like terms, k cubed. We're going to combine their coefficients. 5/3 minus 2/3 gives us 3/3, or k to the third. We wouldn't write 1, and that would be our answer. We would never write 1k. Do not write 1k. Do not write 1k. It's always written as k, or 1k to the third, excuse me. Okay, again, distribution. We're going to distribute. We're going to multiply. We're going to do both of these distributions before adding and subtracting. So we have 3s times 3.2s plus 3s times negative 1 plus 2 times negative 5.8s squared plus 2 times s. That gives us 9.6s squared. This gives us negative 3s. This will give us negative 11.6s squared, and this gives us plus 2s. Like bases or like terms and like terms. So 9.6s minus 11.6s gives us 2s squared, negative 2s squared. We have more negatives than positives, and minus s. It's in standard form, so we're good. That's it? Okay. Awesome. All right. Hopefully that helps. Checking your answers. Pretty sure those are all correct. Oh, this is not in standard form. Boo. Not in standard form. That's good. That's good. That's in standard form. That's in standard form. It says write your answers in standard form. You did not do that. Coefficient has nothing to do with standard form. It's your variable and its exponent that determines standard form. Academic decathlon. Come on.